For this video, I'm going to demonstrate how to use SPSS to conduct a logistic regression analysis. But before that, I want to set the stage for the data set that we're going to use to demonstrate this example. And the data we're going to use comes from a study done by Wench and Podiat, where they engaged 315 college students to ask them whether they should stop or continue research that was being conducted on cats. The cats are being euthanized and their brains are being studied for different purposes. So in these contrived scenarios, they ask students, for example, whether the research should be stopped or continued when using cats for testing cosmetics, basic theory testing about brain functioning, for agricultural purposes, meat production, veterinary research, and medical research. And participants were also asked to take a ethical inventory, which measured their idealism and their relativism. So idealism would be, for example, the more idealistic a person would be, the less likely they would want the research to continue under no circumstances, regardless of the benefits to society. Whereas other people on the relativism scale, the higher the relativism scale, the more open those individuals were to using or to continuing the research if it benefits society. For example, if it would improve the health of cats, or if it would be a benefit in terms of medical research for humans. So the data we're going to use is set up in, for the decision, is coded as 0 to stop the research, 1 to continue the research. Then we have the idealism and the relativism scores, and then we have the characteristics of gender, and then we have the conditions under which students were told that the cats were being used for in terms of the research. So some students were told the cats were being used for cosmetic purposes, some to understand theory, some students to understand that the cats are being used to understand the effects of hormones on meat production, some for veterinary purposes, and then there was one other group that was told the cats were being used for medical research. So to do the logistic regression analysis, we go to Analyze, Regression, and Binary Logistic. And then we put decision in the dependent variable box, because the decision whether to stop or continue is what we're using these variables to help us to predict. And then we'll put the rest of our independent variables in the covariate box, and then we can go OK. So you see in this output, we know that there's 315 data points or students in our sample, and that the way that the dependent variable is coded, stop is 0, continue is 1. And what we see is that for this particular group, we had 187 students who indicated that the research should stop, and 128 that the research should continue. And so we don't have any predicted values yet because we haven't looked at the analysis, but the percentage of continue based on the overall study was 59.4%. So we want to see if we can improve that percentage correct of classifying whether students would make the decision to stop or continue based on the variables that we've added into the equation. And if we look here in this first block, we can see that if all variables are added into the equation, they do significantly predict whether students will make the decision to stop or continue the research. We also are provided with what's called a pseudo R-square, and the one that's most frequently interpreted is the Naglikerke R-square, and we can read this similar to what we use in ordinary least squares regression, that about 33% of the variability in decision making is due to this combination of independent variables that were included in the model. However, you want to be careful in interpreting it in that matter, and you should read more about the use of the pseudo R-squares for interpreting model fit for the logistic regression analysis. Another important table is the classification table. And we can see that our overall percentage of classification based on the variables that were entered into the equation is 72%. So that's a good indicator that the model is doing a good job, better than what the original percentages were, because we have more information with which to make those decisions. So you can see when we interpret this table, so the observed decision to stop, there were 152, and the predicted decision to stop was 152. And so to continue, they said to stop, but it was predicted that they would continue. So these are erroneous predictions. Okay. Now we observed that 54 said to stop, but we actually predicted that 74 would continue. And so these are agree with our data. But here we had, they observed 54 to continue, and here we have 54 to stop. So these are erroneous predictions as well. But overall, our hit rate, or our prediction rate, based on this analysis is 72%. If we look at the variables in the equation, we can see that these beta coefficients are similar to what we see in multiple regression, and we can see that most of them significantly contribute to predicting decision making. In this case, idealism, relativism, gender, theory, and meat production were significant predictors of whether a individual would decide to stop or continue the experiment. And so if we look at, let's just say, relativism, what's really important to interpret here that helps us to understand the contribution is the expected B. In other words, another name for this is the odds ratio. So for every 1 point increase on the relativism scale, or 1 point change, the chance that they would make the decision to continue increases 1.3 times, or almost 1.4 times. With gender, it's much larger. And the reason we have this positive 3.5 is because males were coded 1 and females were coded 0. So in this case, males are 3 times more likely to continue the experiment than females. In terms of idealism, we can see that this is less than 1, And our break-even point is really 1. That means there's a 50-50 chance. And so actually, for every increase in idealism, every unit increase, the 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 probability of making a decision to continue only increases by about 0.5 times. So it's less than 1. So I hope this helps you to understand how to do the logistic regression using SPSS.